Okay. Yeah, so it will be same, it will be same like before, like IPv4. You can go to your PC and you can enter manually. Or if you have a DHCP server in your IT system, any device will get the IP automatically. And we did say that for the link local is a IPv6 address that identifies the link between your PC and the router. So for your PC, this is the link. Usually it's automatically set up. Yeah, so for IPv6, you can do it manually or via DHCP server. There is nothing special. And IPv6 must be careful because you can mess up. That's why it's good to have a DHCP server that will automatically manage and properly. All these things, it's only some reading we don't need. It's only some, what we need the most is to configure IPv6 on an interface. As you know, with IPv6, we have two addresses, a link local and a normal IP address. These two, when you configure IPv6, you must use these two. All these info are given to you in the question paper. Yeah, anything else, it's only some readings, but we don't need the DHCP, and your DHCP will activate. Yeah, we don't need all these. The, the DHCP server will automatically manage everything. And you need to enable. So also, if you use IPv6 in your system, before you start doing your configuration, you must have this command IPv6 unicast routing for all the interfaces, all the network to start sharing IPv6. Then you can create your pool, the same thing we did for IPv4, your server, and so it's not difficult. Sometimes in AutoCAD, they give so much info and the student gets confused at the end of the day. That's why I prefer giving you what is the most important, what we need for our packet tracer and all this stuff. Let me allow someone in. The chapter that is most important is the FHRP. It's very simple. 1 minute you should know. I'm going to show you. What is it about? First hope redundancy protocols. I'll explain to you now. 1 second. I'm checking something quickly. Okay, I can do that later. Okay, first hope redundancy protocols. It's like a backup for routers. 1 minute, we are done. I'll explain to you why. So here, for example, you have in your company a lot of PCs, and they need to go to the internet via your ISP. If you have only one router and the link fails, for example, you can no longer go to the internet. So you need a backup, let's say 2 routers. In case one fails, the other will take over. But the system for first hop redundancy protocol is, okay, router 1 and router 2, the main router and backup router, I'm going to combine them in one virtual router, in one box, so that if one fails, automatically the other one takes over. So I put them in one box in the yellow thing. Now, PC1, we know that we need to enter what? The IP address, subnet mask, and default gateway. If I put the default gateway of router 1 in PC1, in all the PCs, it means all of them to go to the internet, they must go via router 1. So if router 1 fails, none of them will go to the internet because the gateway to go to another network is via router 1. If you do the same thing for router 2 and it fails, no. So what's the system to avoid all this? We combine router 1 plus router 2 in one virtual router. That virtual router will never fail because at least if one fails, the other takes. Now, the default gateway of all these PCs will be what? The default gateway of the virtual router. You see, so that these PCs won't feel if R1 is down or R2 is down. At least one of them will pick up to continue the traffic.
Max, I got a
So,
question on that.
yeah, no problem.
Sorry, Lorenzo here.
Yes, Lorenzo.
So so the 192.0.2.100 is a virtual interface, ne? Now, how does a
Yes.
virtual interface route to any one of the routers?
Okay. So there is a configuration for that. So this virtual router is not a physical one. In fact, it doesn't exist. It's only a config so that if the main one fails, the other one will take over.
Okay, okay.
Yeah,
I think
it's
that's
not a
good.
physical one. It's a system to say for so that these guys, these PCs won't feel it, won't seal it like ESCOM.
Yeah,
If ESCOM goes off, we all notice that we don't have power at all. But if you had a plan B, even the main ESCOM is down, the other one will take over automatically. We won't feel it that there is load shedding or something like that. So it is a nice config for that. We're going to check. So for now, you can read this and we continue. Okay, so there is a short configuration for that, and that's all for this chapter. Anything else, it's only some theory. So the system to combine both router in one virtual, and we have a lot of protocols doing that. Uh, Let me allow some people in. Yeah, so we have a lot of, how do you call it? A lot of protocols that we can use to do that. The most used is HSRP, hot standby router, but we can use any of them. So this one is also good. You can check that. So Okay, we'll get time to. But if you understand the concept, that's all. Anything else is only some reading. So you see here also the same thing. We have all our PCs around our switch, and it can go to the main router, that is active router. The other one is on standby. In case the active router fails, the standby goes kick off. So the system is to combine these two routers in one virtual router, and all information of that virtual router will be sent to each PC, like the default gateway. When we configure how R1 will be identified as the active router is the highest priority. We configure the priority ourselves. And here is 150, the other one is 100. So automatically this one is elected as the active router or the main router. So we'll do a short config and that's all, nothing else. You can also check this. Someone want to get in, who is that? Guys, you must log on earlier. That's why I'll always tell people in advance. I'll be open at that time. So this one is very important. If you understand, we just need some one config and done. So one more minute for you to read and to check the design. Okay, so this is what we'll be doing for this chapter. How to combine two routers in one virtual router so that if one fails, the other takes over, and make sure all the PCs want to feel it. No breakdown, no, yeah, it's automatically done. The employees will not notify anything, we won't notice anything. So this is what, now there is something called preempt, a command that we're going to use. Let's say R1 is the active router, the big boss, the main one. It fails. The other one, the backup router will take over. Then you, as the network engineer, you can fix R1. If R1 is up and running and you want it to become again the active router to take over R2, you must use in the command standby preempt. So you can read this one. If you have questions, you can let me know.
Hi, Max.
Yes,
Max, in what mode do you do that?
because it's a configuration, we do everything in the global config mode. I'm going to show you a config shortly. So for now, you can read here to have the big picture. Then I'll show you a config and we are done. Okay, so let's check an example of configuration. Um, I'm going to show you. CCNA to notes. F HSRP. Yeah, this guy here. Oh, it's gone. Yeah, I think. Okay, anyway. So yeah, this is an example of configuration. Why it goes down? Okay, anyway, you can go and find it. STP, we know that these things will do some labs. So we have a lot of labs to do, and so next Saturday, please, if you can come. Research channel also, we have some labs. So we'll try to clear quickly all these theory things. Then we'll do a lot of labs. The DHCP server, we'll also do some labs for that. HSRP, this is this command that we'll be doing for this lab, nothing else, and we are done. So configure HSRP in the lab that we'll be doing, everything will be given to you step by step. So we are on R1, the big boss. And this interface G01 is facing the LAN, the PCs. So we say, okay, that interface, standby version, specify HSRP protocol version number. The most recent is version 2. Then we'll show you, you type standby version 2. Then this IP you see is the IP address of the virtual router. All these info are given to you in the question paper. So configure IP address of a virtual default gateway. So this IP will be given to all the PCs as a default gateway. It's the IP of that virtual router. This address must be configured on any host that require the services of the default gateway. It replaces the physical interface address of a router that has been previously configured on the host. So we don't use R1 or R2 this interface as a default gateway to a PC. No, we use for the virtual router. Then we add the highest priority because we want R1 to be the big boss. So standby 1 priority 150 and standby 1 preempt. So we keep the 1, you see here the number is just to identify the combination, the grouping. Let's say grouping 1, R1 and R2, R1 plus R2 in one group. That's why we say 1. Everything should be 1. Highest priority to be the boss and standby 1 preempt. In case R1 fails and R2 takes over, if R1 comes back live, it will take over automatically to become again the main router. So this is the config we do on R1. On R2, we do the same thing, except the priority that should be less than 150. It can be 100, but anyway, something less than 150. And we don't configure preempt because we want R1 to become the big boss in case it goes live again. That's all for this chapter. So you can check 2 minutes and we continue. Let me see. Zoom in. Doesn't zoom. It's coming. Anyway, let me remove this one. Yeah, it's here. So that's all for this chapter. It's what we'll be doing for the labs. Yeah, so that's all. Any questions? Anything else we'll be doing yeah, during the lab. So to date we did until we are here, chapter 1 to 9. On Wednesday we'll do land security. Then normally in 2 weeks time, by end of this month, we should have finished. Then we have 2 to 3 weeks. We do a lot of labs as revisions. So Saturdays also we go to CPUT to do labs and yeah. So land security concept quickly. I'll just show you 1 minute what is in for Wednesday. Okay, this is something that we'll be doing. Okay, so we'll check endpoint security, access control, layer 2 security threat, MAC address table, and LAN attacker. This one will be a bit longer. We'll check what are some attacks on networks, different types. What are some security devices to mitigate these attacks? How to protect the endpoint. We have all our endpoint here. So to protect them, we need some devices like firewalls or email security appliance or web security appliance. So to protect our network, we need to put in place some strategies. It depends on how big is the company and also. AAA authentication, authorization, accounting, identity search engine to identify who is who in the company. We'll check a bit of Cisco email security appliance to secure the emails, to secure the web, access control. Yeah, we'll check all this on Wednesday. Triple A. I think we did that in CCNA 1. Yeah, so we still have a lot to learn. Any questions before we close the session for today? Okay, so thank you very much, guys. Wednesday we'll do land security concept. Saturday we'll be at CPUT to do some labs for VLAN and inter-VLAN routing. The following Saturday we'll do STP. The following Saturday we'll do Ether channel. The following Saturday we'll do lab for FHRP, and until we finish everything. Also, please try to do your chapter exams. I think we are activated already. Try to do them. Thank you very much, guys, for today. Have a good evening, and see you next time.